Hello everyone. Now we are going to learn about half-adder in structural style of modeling using VHDL, right? This is the VHDL program for half-adder in structural style of modeling. And we know the structure of any VHDL program contains three parts: library declaration, entity declaration, and architecture body. In library declaration, we use different packages which are defined in the library IEEE, and this is the way we declare the library, which we have discussed already in previous two programs. And now coming to entity declaration, the half adder entity declaration also we have discussed in the previous two programs. We just verify. In entity declaration we mention what are the various input ports and output ports, and the architecture body contains the internal details of the entity, and the relation between the input and output ports are expressed in the architecture body in different ways. One is data flow style of modeling, and behavioral style, structural style, and mixed style. For data flow style, we need Boolean expressions, and behavioral style, we need a truth table. Both the types we have discussed in the previous videos. You please check for them. And now in today's class, we are going to learn about the structural style of modeling, where we need the logic diagram for the logic circuit. Now, and also we have fourth style, that is the mixed style of modeling. The above three or any two can be mixed. Now coming to the half adder, this is the half adder and this is a truth table which we have discussed already. And from the truth table we can write some expression. Sum is a bar b plus a b bar. So same thing we have written. This is the Boolean expression a bar b plus a b bar, which is a XOR with b. And carry is equal to ab, because when both inputs are high, then carry is 1. Therefore, carry is equal to a b. And if you want to go for behavioral style, you can use this truth table. If you want to write data flow style, you can use these Boolean expressions. And now we are going to write the structural style of modeling, right? In structural style, these are the two components we have here. We need the logic diagram, and logic diagram contains two logic gates. One is exclusive OR gate, second one is AND gate. So therefore, those two components we have to declare in the architecture body. So component declaration we see. Component XR2. This is the name of the gate that we are giving. You can give any name. So here component XR2, it is port. We have to mention in this what are the input ports and output ports of this logic gate. So port X comma Y, and they are of bit type data. So in bit and Z out bit type data, and end component. So this is the component declaration for exclusive OR gate. And similarly, we write component declaration for AND gate. So for AND gate, we are giving the name AND2. So component AND2, and then port. What are the inputs? L comma M, just some random number names we are giving. They are in bit type data, and N is the output port, which is also a bit type data, and then end component. So we are using two components, exclusive OR gate and AND gate. So these two components are declared here. It is called component declaration. Now let us see how we write the architecture body in structural style of modeling. So architecture, and the name of the entity is the same, whether you write behavioral style or data flow style or structural style, entity can be same, architecture body can differ. So we are writing this architecture body in a structural style of modeling. Therefore, we have used the term structure. And then in this structure architecture, first we have to declare the components. So component XR2 and port X comma Y in bit type data and Z out bit, and end component. Similarly, AND gate component declaration we have to write here, and the same component declaration, that syntax we have seen here, same components we have written here, right? So with this, in the architecture body, we have defined both the components and their declarations. Now let us see the architecture begin. That means let us see the architecture body with the respective statements. Begin. X1 is XR2 port map with A, comma B, comma sum. Now, what is this X1? Let us see. In this diagram, you can see this is XOR gate. Therefore, you can write X1 is equal to X1 is XR2 port map with A, comma B, comma sum. That means XR2 is the exclusive OR gate and it is port mapped with these ports. So these ports are mapped. So A is the input that we have here in our logic diagram. So it is port map with this X and B with the Y and sum with Z. So X1 is XR2 port map A, comma B, comma sum. Similarly, you can define what is A1. A1 is AND2 port map with A, comma B, comma carry. So here we have AND gate and it is A, B, and therefore we port map this AND gate and AND2 port map with A, comma this L will be mapped with A and this M will be mapped with B and this out will be mapped with N will be mapped with carry. So like that we port map the ports in structural style of modeling. After that we write end name of the architecture body. Right. So in this way we write the complete program, VHDL program for half adder using structural style of modeling. These two lines, library declaration, library IEEE, use IEEE dot standard logic 1164.all, and entity declaration, entity half adder is port A, comma B in bit type data, sum and carry out bit type data, end half adder. Then architecture half adder structural style of modeling, half adder is component declaration and a component XR2 and the ports of this component are X, comma Y in bit type data, Z out bit type data, and end that component and component next one AND gate. So component AND2 and it has ports L, comma N, M in bit type data, and out. That means N is the output port with the bit type data end component. So like that we declare the exclusive OR gate component and also AND gate component, and these components we instantiate here. So component instantiation takes place here. So begin X1 is XR2 port map A, comma B, comma sum. With this statement, what happens means these ports will be mapped. A will be mapped to XR2, X will be mapped to A, and Y will be mapped to B, and Z will be mapped to sum. Similarly, for this statement, we have AND gate here. L will be mapped to M, L will be mapped to A, and M to B, and N to carry. Like that, we declare component and we instantiate component here in structural style of modeling. Hope you have followed this lecture, and thank you for your patient listening. May God bless you. If you have any doubts, you please mention them in the comment section.